the first thing you need to do is you need to go to aplusstudents.com to the website. Then you need to select math as your subject. This is a grade 10 lesson, okay? Grade 10s. And the topic for today is parallel and perpendicular lines. Okay, this is the name of the topic. I'll give you the chapter number and the lesson number. Just a minute, please. So the chapter number is 26 and the lesson number is 6. So let's put it down. Chapter number 26 and the lesson number is 6. Okay. And the name of the lesson is proofs involving parallel lines. Okay. And this is number 1. We'll have 2 on these, right? We'll have 2 lessons. So the first one is, the question given to us is, I'll just copy the questions and the given information, then we'll see what do we need to do, okay? Okay. So for the given question that we have over here is, the first question says, this is the information that is given to us in question number 1. And they say that we have a pair of parallel lines. The parallel lines are defined by WY and TV, right? And we have 3 label points on that. They say WXZ, WXZ and SUT are supplementary angles. Complete the proof that TV is parallel to WY, right? So we are given these 6 statements and we need to see whether they are true or not, right? So we say that this is, the first statement already says this given information, right? They're supplementary angles, right? So it's already given to us over here. Okay. The next angle we say is W, Y, W, X, Z, this angle, SUT. SUT is this angle. Okay. They are supplementary, agreed. SUT and TUX, this given angle, with this angle, it's still supplementary, right? Third one is WXZ, right? What is WXZ? We need to find the missing statement over here, right? To show that they're parallel. So can we say that WXZ, WXZ, SUT, SUT should be equal to SUT and TUX, right? Should be equal to this. Yes, they are equal angles, right? Then the next one is WXZ. Is it readable? Okay. If it's not readable, please let me know. The next one is WXZ should be equal. WXZ should be equals to TUX, should be equal to this angle. Yes, it is true. Why? Because these 2 lines are parallel. If only they are parallel, right? The statement that we can write is, since all the other properties, that the 5 properties that are given to us, they are true, then we can say that these 2 lines will be parallel if they are converse, right, of corresponding angles, right? And we say postulate. Okay. The term corresponding angles of the term postulate means that, let's suppose if I'm just giving you an example over here, and we had this over here, right? If I would label this as A, B, C, and D, right? If the first given angle was ABC and the second angle was CBD, so we can write ABC when added to CBD, their sum should be equals to A, B, and D. It should be equal to the complete angle, right? This property is known as converse of corresponding angles postulate. So we just need to define what exactly is the property over here, right? So we are looking into just one property for now, that is converse of corresponding angles. Okay, moving on to the next question. That's question number 2 that we have is, let me just copy it for you on the screen. They are again asking us to find the given information, right? In question number 2, what they are asking us to do is to look at the given information and find the missing property. Okay, we have pairs of parallel lines, agreed, and they are giving us supplementary angles as well. They've told us that these two angles, we have been told is that these two angles are supplementary. Okay, these two are supplementary angles. This information is already given to us, right? S, T, W, T, W, and V. Okay, this is already given that the sum of these angles, the interior angles between two parallel lines will have a sum of 180, right? Which is proved over here that they would sum up to. Okay, then we have RTS. Where is RTS? RTS, this angle, this RTS, plus STW. Where is STW? STW was this. That means angles formed on a straight line, the sum of these two angles would always be 180, right? This is already given to us. Then what they're saying is STW, this angle, plus TWV. TWV should be equal to RTS, this angle, STW. STW should be angle to this. These are corresponding angles, right? And they are equal. The next statement is TWV. We can see TWV, this angle, should be equals to RTS, RT, and S, right? We can prove it through algebra because there is a pair of parallel lines. So what can we say about the parallel lines? We will use the same statement and we will say that these two angles are converse of corresponding angles postulate. Okay, this is just, we need to give a reason that would define that the line SU, the line SU, why is the line SU parallel to XB, right? That the condition is converse of corresponding angles postulate. Okay, moving ahead with this, we move on to the next. Are there any questions till now? Okay, let's see for the next question. What proof that do we need to provide to prove this? Okay, I just copy the next question. The question number 3 states that, okay, if question number 3 is given to us, this is our question number 3. And question number 3 states that complete the proof that MUX, where is MUX? Oh, sorry, UXY, UXY, this angle, UXY, VUX, where is V, U, and X. These two angles would sum up to 180 degrees. We need to give the proof, right? The first thing we need to do is we need to see if they have given us a pair of parallel lines. So they say that these two lines are parallel, right? And it's given already. If in the question they are saying these two lines are parallel, that means we'll have a set of corresponding angles, right? So can we say that U X, Y, where is U, X and Y, this given angle is approximately equal to SUV, right? And they are corresponding angles, right? Postulate. The other one is SUV. SUV, this angle, VUX, where is VUX? VU and X. And this angle, whenever we have angles being formed at one point, their sum would always be 180, right? Agreed? They would sum up to, angles on a straight line always sum up to 180 degrees, right? So we need to look at the last condition, okay? So the last condition is, we need to give a reason for that. Let's see over here. UXY, this is UXY, UXY, this angle plus VUX, where is V, U and X, right? These two angles are equals to 180, right? So what is the reason for that? The reason for that is they are interior angles, right? Between two parallel lines. So we say that they are substitution. Okay, these two angles are regarded as substitution, where we have one line, we have two pairs of parallel lines, and we say that the sum of these interior angles X and Y, X plus Y, would be equal to 180. Why? Because if this angle was X, then this angle was X. If this angle was Y, then this angle would be Y, because there is a pair of two parallel lines intersected by a slant, one single slant line. Okay, do we agree? Okay, thank you. Moving ahead for the next question, what we can say is, let me just copy it. Okay, just a minute, please. Okay, for question number 4, so we have seen two properties right now: converse of corresponding angle postulate and substitution. For question number 4, let's see how we can complete the proof. Okay, so for question number 4, it says we have two pairs of parallel lines, right? Let's see which are the two pairs. They would be given us QS and TV, right? These are the two pairs of parallel line that are given to us. Yes, it's given already in the question. What they are saying is TUW. Where is TU and W? This angle is approximately equal to QRU. And these types of angles are known as, if these two lines were parallel and these two angles were given to us, they're known as corresponding angles, right? That means they are exactly the same. So moving ahead to the third category, third statement, PRQ, this angle plus QRU plus this angle. That means on a straight line, if we are given this angle and this angle, the sum of these angles should be 180. Sum to 180. That's agreed, right? And for looking at the last option, that is TUW. TUW is this angle plus PRQ. Where is P, R, and Q? This was PRQ, right? We already have seen this, that if we have a pair of parallel lines, then this angle and this angle would sum up to 180. Let's see. If this was X and this was Y, if we are writing X plus Y is equals to 180, let's confirm. If this angle was X, then this should be X. If this was Y, then this should be Y. And through this previous, we saw that the sum of these two angles would be 180 over here and 180 over here. Therefore, X plus Y is proved to be 180 and it is known as substitution, right? Okay, it's known as substitution, that we are substituting the values of the angles and we are saying that these two angles X and Y are equal. Moving on to the next. Okay, let's see next. And question number 5 we have is complete the proof that they are supplementary. Okay, let me just copy this. For question number 5, if this is question number 5 for us, let's look at the question. They're saying the first line says they're parallel lines, right? So can we mark the parallel lines? We say this set and this is a set of parallel lines, which is already given in the question, okay, in the statements. And what they are saying is complete the proof that RUV, this angle plus SRU, this angle is 180, right? We need to prove this. We need to give a proof for this, right? And we know that whenever we have set of two parallel lines, we just did in the previous question, right? If this was parallel, if this was angle X and this was angle Y, so can we say this is angle X, right? And if this was Y, then this would be, so we can always say that X plus Y was 180, right? We know this proof already, and we know that this is done through substitution, right? But before that, let's look at the second statement. RUV, where is RUV, this angle, PRS, yes, corresponding angles, agreed? They both are corresponding angles. The third statement we have is PRS plus SRU, SRU plus this. That means angles formed, this angle and this angle formed would always be 180, right? Sum of the angles is 180. So the last statement would be substituted by, what do we say in the last statement? RUV where is R U V, this angle, plus S R U plus this angle. Whenever we have a pair of interior angles between two parallel lines, we say the sum is 180, and that is known as substitution. Okay, agreed? So we give, okay, we say this is substitution. Okay, moving ahead to the next question. Okay, this would be using, I think, a different property. We will look at a new property over here in the question number 6. And question number 6, what they are asking us. Is there any question related to this? Kindly let me know. Okay, if we don't, that's fine. We can move ahead. So if this was question number 6, and they're saying that we need to simplify the next question, that is question number 6. Okay. What they're saying is that complete the proof that these two angles are same, right? SVW, whereas SVW, this angle, and RSV, these two angles are same, right? And we also know that we have a pair of parallel lines. Agreed? That is given in the first opening statement. These two lines are parallel. Let's look at the second statement, right? The second statement says SVU, SVW, this angle, QST. Can we say that these two angles are corresponding angles? This angle and this angle, right? We agree on that? Are these angles corresponding? Okay. So this we agree on. The next one we have is QST, whereas QST, this, and RSV, this angle, right? We know that they are vertical angle theorem, and they are known as vertically opposite they're also known as vertically opposite angles, right? Because whenever we have a formation of X, right, then this angle and this angle would be same. They are vertically opposite angles. Okay. So the last statement says, just a minute, please. It says SUW, SVW, sorry. SVW is this angle, and RSV, approximate. RSV is saying this angle, right? So whenever we have a line and we have a pair of parallel lines, right? So what we can say is these two angles would always be equal. Why? Because if we say this angle was X, then this angle is X. If this angle is X, then this is the corresponding angle over here, and this is vertically opposite to this, right? So what we can say is that these two angles are same because we can say that they have the correct statement is they have the transitive, right, property of congruence. The word congruence means exactly same. In mathematics, the term congruence means exactly same. Okay, so that means they have a transitive property of being the exactly same angle. Okay, any questions up till now? Is there any query, any question that I need to answer before we move on to the next? Okay, good. Let's see the next example we have. Keeping in mind the three properties that we have already done, let's have a look at the next question. Okay, and the next question states that would be question number 7. Okay, let's do question number 7 over here. And the question number 7 states that this is the given information. Complete the proof that these two angles are same. Which two angles? W, X, and Z, this angle, and SUV. SUV, these two angles are same, right? We look at what is the reason for these two. We just did this in the previous question, right? So they are saying that we have a pair of parallel lines. Can we just simply outline those? Yes, we do have a pair of parallel lines, and we have to put in the arrows on either ends, or even one end is fine. They're saying that WXZ, this angle is approximately equal, right, to TUX, or we use the term equal, right? TUX. We know that these two would be corresponding angles, right? If we have this, then these two angles are corresponding angles. The term is given. It's already given as a proof to us, right? Third statement says TUX, right? TUX, this given angle, and SUV is this angle, right? Vertical angle, or vertically opposite angles. And this happens when we have a formation of X. So this angle would be equal to this angle, right? That is a vertically opposite angle. So we could have said this is SUV and this was TUX, right? So these two angles would be equal. What we need to find is the missing statement. The reason for the missing statement, it says WXZ, this given angle is equal to SUV, right, to this angle. So if we draw it separately over here and we show that we have pairs of two parallel lines, what they are saying is this angle and this angle should be equal, right? Let's see how can they be equal and what they are called. We just did this question in the previous. That was transitive property of congruence. This was transitive property of congruence, right? Let's see what we can say. If this angle was X, then this should be X, right? And we know that these two would be vertically opposite. If this is X, then this would be X, or this is X, then this is corresponding also, right? So this is the transitive property of convergence. So we need to give our reasons. Why are we saying that these statements are true? Okay, so these are the reasons for that. Okay, so moving ahead to the next question, do we have any query regarding what we have done up till now? Any questions regarding that? Okay, let's move ahead to the next one. Okay, for the next question, what we can see is, let me just copy this. Complete the proof that this and these two angles are equal. We need to prove that. Why these two angles are equal? That is question number 8. This is our question number 8. Sorry. Let's write question number 8. And the statement says, create the proof that these two SRU, this angle, and RUT, where is R, U, and T, and this angle. We have the same shape as the previous question, right? These were the same. So let's see, why are they exactly the same? Okay, moving ahead with the question, we say that they've already given us a pair of parallel lines. That is already given to us. We can mark these lines. We say this line was parallel to this line. It's already given as a statement. We say RUT, where is R, U, and T, this angle, PRQ, PRQ. And we know that whenever we have pairs of parallel lines and a line is intersecting, then these two angles are always known as corresponding angles, right? We agree on that? That is a pair of corresponding angles. Moving ahead, can we say that, it says vertical angle theorem, right? And we know that vertical angle is basically vertically opposite angles, right? That means whenever we have a formation of X, that these two angles and this angle, right? These pairs of angles would be vertically opposite. And similarly on the same diagram, this angle will be vertically opposite to this angle, right? So we look at the formation of X intersecting lines. So can we say PRQ, where is PRQ, and SRU? SRU. So we said that these two angles were vertically opposite angles. Agreed? Because we can show it over here that these are vertically opposite angles. What about the last statement? In the last statement, what they are asking us to do is SRU, this angle would be equal to this angle, right? So we had two parallel lines and a line was intersecting. They are saying that these two angles would be same. These two angles are only same because if this was X, then this was vertically opposite X, and this X is corresponding to this X, right? So we can say that this property is known as transitive, right? Transitive property of congruency. Okay? Transitive property of congruence. And congruence means that the word congruent means in mathematics is it is exactly same. Okay? Moving ahead to the next question. The next question what we have is, let me just copy this so that for the next question that we have is 5 properties are already given. We need to find the missing 6th property. Question number 8. Let's make it question number 9. And the question number 9 states that this, okay, if this is question number, sorry, if this is question number 9 for us, okay, sorry, I just need to redo it. Okay, it's missing over here, question number 9. I'll just rewrite this statement. Just a minute, please. I'll recopy this, copy and paste. Okay, we have this question again. This was question number 9. And what they're asking us is find the missing statement. They have, see, whenever they have a missing parallel line and they want to ask a statement for that, we already know the answer, right? We know that it would be converse of corresponding angles postulate. But before doing that, the answer would be converse of corresponding angles postulate. Okay, whenever they will give you to prove that these two lines are parallel, you will give this reasoning. Whenever they will give you something like this, this would be transitive property, right? So we already know that the answer would be converse of corresponding angle. But let's see how it is, right? In this question, what they are saying is these two angles are supplementary. So can we say PRQ and TUW? This angles would be supplementary, right? Can we say that these were the two parallel lines? If this was the angle X and this was angle Y, so this would be angle X and this would be angle Y because they are corresponding. So we can say the sum is 180. We can say the sum is 180, right? They both are supplementary angles to each other. So the next part says PRQ. We just need to remember whenever they're asking how to prove parallel lines, we say converse of corresponding angle postulate. That is the reason for us. That is the specific reason we can give, right? We wrote the reason ahead of time, but we are just trying to prove that. PRQ plus TUW. TUW, this angle would be 180. We just did that, supplementary angles. Okay. The next one is PRQ plus QRU, right? That is again 180 because angles forming at a point on a straight line is always 180. Okay, let's look at the transitive property. PRQ plus TUW. These two would be they should be equal to the interior angles. PRQ plus QRU. Where is QRU? Right? So we knew that the sum of this angle and this angle would be 180, and the sum of these two angles would also be 180, right? So we call this transitive property of equality. We need to remember this because in one of the few questions, they can miss out this property and they can ask us, like, what is this property really known as? So we would say this is transitive property of equality. And the last part, we can say that TUW, this angle would be equals to QRU would be equals to this. Yes, that is true. That is the algebra part, that they are equal because they are corresponding, right? So we can say the property that defines parallel lines is always known as converse of corresponding angles postulate. Whenever we are missing a property for the parallel lines, we'll write down the statement. Okay. So let's look at the next question. We'll try a question or two more. Then we'll try to do a question from the test. Okay. So the next question we have is this, and I'll just copy it down on the screen. It will not fit in over here. Question number 10. Okay, let's see what they're asking us in question number 10. Okay. The question number 10 states that complete the proof. Okay. In this case, parallel lines is already given to us, right? So we do not have to write the previous question statement, because if the parallel line was missing, we would say converse of corresponding angles postulate, right? This would be the given property for this parallel lines, right? But it is already given, so we do not write the name of the property. Okay. So when we look at this question, we have a pair of parallel lines that is already given to us. The next, what are they saying next? W x w y, x w y is this angle, u t w is this angle, right? We know these are corresponding angles. The sum of these angles, sorry, these two angles would be the value of these two angles, UTW and XWY would be equal, right? Moving ahead to the next one, can we say that UTW, where is UT and W, this given angle should be equal to RTS, RT and S. We say vertical angles, or they're also known as vertically opposite angles. So we know that these two angles RTS and UTW are vertically opposite angles, and the theorem is known as vertical angle theorems, right? So moving ahead, the last part that we need to prove is, it says, let's highlight it, the X, Y, W, we have X, Y and W, X, W, Y, this angle, right? And RTS, this angle. We need to give the proof that these two angles are equal, right? Which I've marked over here. So whenever we have a scenario that marks up these two angles, I'll just draw it over here so that we have a better understanding. These are the pairs of parallel lines. We are saying this angle must be equal to this angle, right? So if I say this angle was X, that this angle should be Y, because this sum is 180, right? Or can I say, if this is Y, then this angle should be X, because the sum of these two angles is also 180, right? The sum of these two angles is also 180, right? So whenever we have angles forming 180, it is known as, and they are on separate parallel lines, right? So they are known as transitive property of apologies, I have a sore throat. That's why sometimes you miss my audio, right? So what we need to keep in mind is that whenever you have two angles that are equal and their external angles onto parallel lines, right? Then we say that these two angles are, the property name is, they're congruent angles, but congruent means they're exactly the same, but they are on two separate chiral lines and external angles, right? So we say transitive property of convergence, congruence. Okay. Try more questions. Okay. And if you have any problem, just go through these. Okay. So you will find the names of these properties. Okay. You can, when you're doing these questions, you will find the name of these properties that would help you in solving the questions. Okay. Take care. Best of luck. Have a nice day.